Hi class, so in today's video I'm going to review with you some mole conversion practice problems. Remember that tomorrow there's going to be a quiz on mole conversions, so please take notes carefully and pause the video when I suggest and try the problems out as a class and then see if you get them right. Because I'm in a rush, I'm not going to do any editing on this video, so I apologize if I make any mistakes, then have to go back and fix them. Okay. So remember, there's two types of problems. You convert from grams to moles or moles to grams. Remember, a mole is a counting number, and the number that you're counting to is this very large number, Avogadro's number, 6.02 times 10 to the 23rd. Okay, so in the problems where you're converting from grams to moles, right, you're given some number of grams, and you're going to moles. And you have to cancel out the grams, so you put the grams on the bottom of the fraction. And you put moles on the top. So that's one setup. And if you do the setup, a lot of the times you're going to get the rest of the answer right. In the other problem, you're given the moles, and you're trying to get grams. And you're trying to cancel the moles, so you put it on the bottom. And you want to get grams, so you put that on the top. Notice, in this case, grams is on the bottom of the conversion factor, so this is where you put the molar mass number. Notice here the grams is on the top, so this is where you put the molar mass number. So please pause the video now and make sure you write these notes down. Okay, so in the first problem, you're converting moles to grams, 0.925 moles of CO2 into grams. So you write 0.925 moles of CO2 where you write the given on the left side. And you write grams of CO2 on the right side. Again, remember, because we're going from moles to grams, we're given the moles, so you want to cancel the moles by writing it at the bottom. And you write grams on the top, because notice the top of the answer always matches the answer. So, you notice grams for moles, so you have to calculate molar mass. You know that carbon is 12.01, and oxygen is 16 times 2. And when you do that, you get 44.01. Notice I'm writing it next to the grams. And then you multiply these two numbers. So I typed it into my calculator, this multiplication problem. Remember, there's always a 1 next to the moles. And you get this answer, 40.70925. Now we don't write all these digits. Notice that there's three digits in the given. The zeros in the front don't count ever. So we write 40.7. Notice that after the 7 there's a 0, so that rounds down. So here's my answer. 40.7 grams of CO2. Okay, let's try another one. Another moles to grams problem. 4.75 times 10 to the negative 3 moles of ammonia, or NH3. And you're trying to solve for grams of NH3. You put the moles on the bottom because you want to cancel the moles. You put grams on the top because that's what's in my answer. Okay, I calculate the molar mass of ammonia, and nitrogen is 14.01, and hydrogen is 1.01 times 3, which is 3.03. I add these together, and I get 17.04 grams per mole. Notice that both the numbers on the top, there's always a 1 next to the moles in my conversion factor, so then I multiply these two numbers together. Okay, so I did this math problem in my computer calculator, and I got the answer 0.08094. So you notice that there's 3 digits in my given, so then what I can do is I can make my calculator do my work for me and turn it into scientific notation if I don't want to write it this way. And you notice it comes as 8.094 times 10. This E means times 10 to the negative 2. Now, because the given only has 3 digits, I only write 3 digits. So it's 8.09 times 10 to the negative 2. So I run out of space here. I'm going to write it here. 8.09 times 10 to the negative 2 grams of NH3. Okay, so you try this problem. 82.1 grams of C6H12O6, this is glucose, to moles. So pause the video and try to do it. Take 5 minutes. No more than that. Okay, so remember the given goes on the left. And we're solving for moles, so we put moles of C6H12O6. You put an equal sign. Because we're starting with grams, we want to cancel it, so we put grams on the bottom. We're solving for moles, so we put moles on the top. Notice now, grams is on the bottom, so that's where we put the molar mass when we calculate it. So I calculated the molar mass of C6H12O6. Carbon is 12.01 times 6. Hydrogen is 1.01 times 12. Oxygen is 16 times 6, and that comes out as 180.18. So I always write it next to the grams in the molar mass. And there's a 1 next to the moles. Now, you would multiply by 1, but don't ever multiply by 1. Remember, I take a calculator. And then you divide by 180.18. So 82.1 divided by 180.18, and that gives you your answer. So when I type it in my calculator, I get this huge long answer. And obviously you're not going to write all this down. You write out how many digits? 3 digits. So I write those 3, 0.455. Again, the 0 in the front doesn't count, but notice the digit after the 5 is a 6, so it rounds up. So the answer is 0.456. 0.456 moles of C6H12O6. Okay, again, try this problem as a class, as an individual at your paper. Pause the video, and then in 5 minutes at most, press play to see the answer. Okay, so the given is 9.41 times 10 to the negative 9 grams of CH4. You're solving for moles, which is moles CH4. You want to solve for moles, so you put moles on the top of the fraction, right? Always matches. And the grams goes on the bottom. Remember, the molar mass goes next to the grams, so right there. Okay. So the molar mass of carbon is atomic mass, of carbon is 12.01. Hydrogen is 1.01 times 4. So it's 4.04 plus 12.01, which is 16.05. And I apologize, this other arrow got in the way. 16.05 grams per mole. And there's always a 1 next to the moles. So now you take this number, 9.41 times 10 to the negative 9, and divide by 16.05. Okay, so I plugged it into my calculator, and I got this answer. Obviously, we're not writing this many digits. We're writing 3 digits because it's 9, 4, and 1, 3 digits in my given. 5.86 times 10, right? The E means times 10 to the negative 10 power. 5.86 times 10 to the negative 10. 5.86 times 10 to the negative 10 moles of CH4. You wouldn't write this in regular notation, so remember, you have to learn how to make your calculator do the work for you, and make sure you ask the person next to you how to use your calculator to figure out how to tell it to do scientific notation. There's usually a mode button or a sci engineering button at the top of if you're borrowing one from the substitute today. Okay, so I have 2 more challenge problems. Try to figure out what you're converting to and do this problem. Take 5 minutes by pausing the video. Okay, so in this problem, you're given moles. So when you're given the moles, you have to convert to grams. So I write the given on the left. 9.001 times 10 to the negative 8 moles of CaNO3 and I'm going to solve for grams of CaNO3 calcium nitrate. Because I'm starting with moles, I'm going to put moles on the bottom to cancel it, and because I'm going to grams, I'm going to put grams on the top because it matches, right? Okay, so I'm going to first solve for the molar mass, grams per mole, of calcium nitrate. So remember, the calcium has an atomic mass of 40.08. Nitrogen has a mass of 14.01. There's 2 of them. Oxygen has a mass of 16, but there's 6 of them, so that's 96. And when you add those 3 numbers together, you get 164.10. So I'm going to write that next to the grams. So, because both of these numbers are on the top of the fraction, there's a 1 below, but you don't have to divide by 1, right? I take your calculator away. You multiply these 2 numbers and you get your answer. So when I type it in my calculator, I get this answer. Now if you wrote this answer down, it's correct, but I would mark it wrong because you wrote too many zeros. I don't want to be in the business of counting many zeros, so I want you to make sure that you write it in scientific notation. So I hit my button that changes it into scientific notation. You have to know how to do that on your calculator, and make sure you ask your neighbor if you don't know how. So my given has 4 digits in it, so I write 1.477 times 10 to the negative 5. 1.477 times 10 to the negative 5. Right. Make sure when you write it that you erase this and put this over here. But there's my answer. 1.477 times 10 to the negative 5 grams of calcium nitrate, CaNO3. Okay, so in the last problem, we have 8.020 times 10 to the negative 3 grams of potassium phosphate. So, pause the video, convert it to what you think you need to convert it to, and then do the figure out what you need to convert it to, and then do the prompt. Take no more than 5 minutes. Okay, because you're given grams, you know you have to convert to moles. So you put 8.020 times 10 to the negative 3 grams of potassium phosphate, and you're going to go to convert to moles of potassium phosphate. Because you start with grams, you're going to put grams on the bottom. And because you're solving for moles, you put moles on the top. Notice the grams in the molar mass is on the bottom, so you put the molar mass right there after you calculate it. Okay. Okay, so I calculated the molar mass of K3PO4. K is 39.1. And I realized I did this wrong. 39.1 times 3 plus 30.97 plus 64 for 4 times 16, and that's 212.27. 212.27 grams, and there's always a 1 next to the moles. So you take this number, 8.020 times 10 to the negative 3, divided by 212.27, and then you get your answer. So we'll plug that in. 8.02 times 10 to the negative 3 divided by 212.27. Okay, so you get this huge answer. Now this number has 4 digits in it. 0 is in the middle count, 0 is at the end after a decimal spot count. So again, these are just rules that I'm trying to teach you as you go, rather than just have a whole unit on figuring out how many digits something has, because that would be boring. So this has 4 digits. So you write 3.778 times 10 to the negative 5. Again, 4 digits. So this 2 rounds down. So it's 3.778 times 10 to the negative 5. And there's your answer. So, I hope these problems were useful. Remember, there's a quiz tomorrow on mole conversions for those of you who haven't taken it. So, good luck, and I will see you tomorrow.